All right, so we're right now on enforcing preconditions. So we were talking about preconditions in the previous video, and we came to learn what they are. And pretty much, to my understanding, it's a way of pretty much handling what is this data? What is this error handling and data validation? I wanted to use the word data validation here. So now we talked about, I think the previous video, debugging with accessions. That's what we talked about. And I think we came to learn that there's two parts to this, accessions and preconditions. So we talked about accessions, and right now we're talking about preconditions. And we understand what accessions are. Pretty much what they say is that if a statement is false, then print this or do this. Pretty much that's what they do. Let's see what's going on here with enforcing preconditions. Use the preconditions whenever a condition has the potential to be false, but must definitely be true for your code to continue executing. Okay, I see this. For example, use a precondition to check that a subscript isn't out of bounds, or to check that a function has been passed a valid value. You write a precondition by calling the precondition function. You pass this function an expression that evaluates to true or false, and a message to display the result of the condition if the result of the condition is false. For example, this, it pretty much looks like an accession, but then I wonder what the difference is here. What is the difference? Because they look the same, but we know that they're not the same. You can also call the precondition failure function to indicate that a failure has occurred. For example, if the default case of a switch was taken, but all valid input data should have been handled by one of the switch's other cases. Okay. Note, if you compile in unchecked mode, preconditions aren't checked. If you compile in unchecked mode, preconditions aren't unchecked. The compiler assumes that preconditions are always true. It optimizes your code accordingly. However, the fatal error function always halts execution, regardless of optimization settings. You can use the fatal error function prototyping and early development to create stubs for functionality that hasn't been implemented yet, by writing fatal error and implement it as the sub implementation. Because fatal errors are never optimized out, unlike accessions or preconditions, you can be sure that execution always halts if it encounters a stub implementation. Okay, I didn't really understand what I was reading there, but I think at least we know that there's something called enforcing preconditions. And as we continue here, and because we're doing the basics right now, as we delve deeper, we will be able to see the broader meaning of enforcing preconditions. And also, because the thing about what we're learning here is they won't tell us how to use these things, but they'll tell us about the tool. They'll say, this is the tool, this is what it is, this is how you use it. But then obviously they won't say, in a situation like this. Doesn't make sense. And that's what I like here. So yeah, I think this is the end of it. We'll just end it here. Cheers, guys.